As the radiant sun climbs higher in the sky, it warms the Earth's surface, infusing the air above it with energy. Within this energetic air, a dance of physics and thermodynamics unfolds, giving rise to the ethereal beauty of a cumulus cloud. Let's embark on a journey to unravel the mathematical and physical intricacies that shape the mesmerizing form of a cumulus cloud. As the sun's rays permeate the surface, the ground absorbs solar energy and begins to warm. The heated ground, in turn, transfers this energy to the adjacent air molecules through conduction. With each molecule gaining kinetic energy, their rapid movements intensify, causing the air to expand and become less dense. Buoyant forces governed by the laws of fluid dynamics comes into play. Like a newborn flower yearning for the embrace of sunlight, a warm air parcel emerges from Earth's surface and rises through the cool layers of the atmosphere. Buoyancy, that elegant dance of forces, orchestrates the air parcel's ascent. Its magnitude can be expressed as the difference between the air parcel's density and that of the surrounding air multiplied by the volume and the acceleration due to gravity. This force propels the air parcel upward, carried by the rhythm of convection. As the air parcel soars upward, it undergoes a transformative journey. Adiabatic cooling, a fundamental principle in thermodynamics, unveils its captivating prowess. The expanding air parcel encounters decreasing atmospheric pressure, causing its temperature to drop gracefully. Mathematically, the rate of adiabatic cooling is described by the dry adiabatic lapse rate, typically around 9.8 degrees Celsius per kilometer or 5.4 degrees Fahrenheit per 1,000 feet. This rate captures the delicate balance between the parcel's cooling and the surrounding environment. But nature's poetry is enriched with an interplay of moisture where physics takes on a sublime form. The rising air parcel, in its graceful ascent, embarks on a quest for equilibrium within the moisture laden atmosphere. As it climbs higher, it reaches a point where its temperature aligns with the dew point, which is the temperature at which the air becomes saturated with water vapor. At this juncture, a symphony of condensation unfolds. The air parcel, now infused with droplets of liquid water, manifests as a cumulus cloud. A cumulus cloud is characterized by its distinct, fluffy, and cauliflower-like appearance. It is a low-level cloud that forms in the troposphere, typically below an altitude of 2 kilometers or 6,500 feet. Cumulus clouds are often associated with fair weather conditions, but they can also develop into larger and more vertically developed clouds, such as cumulonimbus clouds, which we will take a look at here in just 1 second. Now, these clouds are definitely pretty scary, guys. These clouds are associated with thunderstorms. Again, these are called cumulonimbus clouds. To understand the physics and mathematics behind the formation of cumulus clouds, we need to consider the principles of atmospheric thermodynamics, specifically the processes of convection and condensation. Convection plays a vital role in the formation of cumulus clouds. It occurs when a parcel near Earth's surface becomes warmer than its surroundings, leading to its ascent. The rate at which the air parcel rises is governed by the laws of fluid dynamics and can be described using principles such as buoyancy. Buoyancy refers to the tendency of an object or fluid to rise or float in a denser medium. In the case of air, when a parcel of air is heated, it becomes less dense than surrounding air and experiences a buoyant force that causes it to rise. This process is commonly referred to as thermal convection. Mathematically, the buoyant force acting on the air parcel can be expressed using Archimedes' principle. This is F is equal to rho times G times V, right? So F on the left-hand side of the equation is the buoyant force. Rho is the density of the air parcel. G is the acceleration due to gravity. And V is the volume of the air parcel. As the warm air parcel ascends, it undergoes adiabatic cooling. Adiabatic cooling refers to the decrease in temperature of a parcel of air as it expands due to decreasing atmospheric pressure during its ascent. The rate of adiabatic cooling depends on the lapse rate, which is the rate at which the temperature changes with altitude. The lapse rate is vertically divided into 2 types, the dry adiabatic lapse rate and the saturated adiabatic lapse rate. The dry adiabatic lapse rate is approximately 9.8 degrees Celsius per kilometer or 5.4 degrees Fahrenheit per 1,000 feet, while the saturated adiabatic lapse rate is lower, around 5 to 6 degrees Celsius per kilometer or around 2.7 to 3.3 degrees Fahrenheit per 1,000 feet. The saturated adiabatic lapse rate applies when the air parcel becomes saturated with water vapor, leading to the formation of clouds. As the warm air parcel rises and cools, it eventually reaches its dew point temperature. The dew point temperature is the temperature at which the air becomes saturated with water vapor and condensation begins to occur. Condensation is the process by which water transitions into liquid water droplets, forming the visible cloud. The formation of water droplets within a cumulus cloud is influenced by the presence of condensation nuclei. Condensation nuclei are tiny particles suspended in the air, such as dust, pollutants, or aerosols. These particles provide a surface for water vapor to condense onto, forming cloud droplets. The concentration of condensation nuclei affects the number and size of cloud droplets within a cumulus cloud. So in summary, guys, a cumulus cloud is formed through the process of convection, where a warm air parcel near the Earth's surface rises due to its buoyancy. As the air parcel ascends, it cools adiabatically and reaches its dew point temperature, leading to the condensation and formation of cloud droplets. The distinctive appearance of cumulus clouds arises from the growth and aggregation of these droplets. The physics and mathematics behind the formation and dynamics of cumulus clouds involve complex interactions between temperature, pressure, humidity, and the principles of fluid dynamics and thermodynamics. The processes of convection, adiabatic cooling, and condensation play crucial roles in their development. So to further understand the dynamics of cumulus clouds, we can consider additional physical concepts such as the concept of buoyancy and a vertical motion within the cloud. Buoyancy, as mentioned earlier, is the force that causes warm air parcels to rise. It can be quantified using the equation F equals rho Vg, where rho is the density of the air parcel, V is the volume of the parcel, and G is the acceleration due to gravity. When the buoyant force exceeds the opposing forces such as gravity and atmospheric resistance, the air parcel continues to rise and forms a cumulus cloud. Within the cumulus cloud, vertical motion is driven by convective updrafts and downdrafts. Updrafts are ascending currents of air, while downdrafts are descending currents of air. Updrafts occur due to the release of latent heat during condensation, which further enhances the buoyancy of the air parcel. These updrafts contribute to the growth and vertical extension of the cloud. The dynamics of cumulus clouds can also be influenced by various factors, including the environmental lapse rate, moisture content, and the stability of the atmosphere. The environmental lapse rate refers to the actual rate at which temperature changes with altitude in the surrounding environment. If the environmental lapse rate is steeper than the dry adiabatic lapse rate, it can lead to increased instability, promoting stronger updrafts and taller cumulus clouds. Conversely, if the environmental lapse rate is more stable, it can suppress convection and limit vertical growth of clouds. Moisture content is another important factor in cumulus cloud formation. Higher moisture levels provide more water vapor for condensation, leading to the formation of larger and more developed clouds. The availability of moisture is crucial for the cloud to sustain and maintain its structure. So basically, guys, in summary, cumulus clouds are formed through the process of convection, where warm air parcels rise due to their buoyancy. Adiabatic cooling and condensation occurs as the air parcel ascends, leading to the formation of visible cloud droplets. The dynamics of cumulus clouds involve vertical motions driven by convective updrafts and downdrafts, influenced by factors such as environmental lapse rate, moisture content, and atmospheric stability. Understanding the physics and mathematics behind cumulus clouds helps meteorologists all around the world predict weather patterns and analyze atmospheric conditions. All right, guys, thank you for sticking with me so far. If you're still here watching the video, definitely please make sure you hit that like button. If you're enjoying the content, definitely hit the subscribe button to our channel. Definitely leave a comment down below and let me know if you have any pictures of cumulus clouds that you would like to share. You can send those to worldweatherauthority@gmail.com. That would definitely be appreciative. We can definitely include some of your pictures in our presentations as well, with your consent, of course. But let's continue, guys. Cumulus clouds represent a specific type of cloud formation in the atmosphere. They are characterized by their distinct fluffy and cauliflower-like appearance, like we talked about, with well-defined edges and a generally flat base. The images you're seeing here are of cumulonimbus clouds and various other clouds as well. This is actually more of a thunderstorm type of cloud. So it's pretty neat. The presence and characteristics of cumulus clouds can provide valuable information about atmospheric conditions and weather patterns. So some key details about what cumulus clouds represent. Let's start with this one: stability and atmospheric conditions. Cumulus clouds can indicate the stability or instability of the atmosphere. So it's definitely pretty interesting. If the cumulus clouds have well-defined cauliflower-like structure with upward vertical growth, it suggests an unstable atmosphere. This instability can lead to the development of convective processes and the potential for thunderstorms and other intense weather phenomenon. So it's definitely pretty crazy. Interesting, for sure. Conversely, if the cumulus clouds appear relatively flat and have limited vertical growth, as you see in this image here, it indicates more of a stable atmosphere with less convective activity. And we can talk about these clouds here as well. These are known as fair weather cumulus clouds. So cumulus clouds are often associated with fair weather conditions, especially when they are small and isolated. These fair weather cumulus clouds form as a result of localized convective processes where warm air rises from the surface due to heating and thermal convection. So the vertical growth of cumulus clouds is fueled by the release of latent heat during condensation, creating the characteristic fluffy appearance. Fair weather cumulus clouds typically do not produce precipitation, and their presence indicates a relatively calm and stable weather pattern. While small cumulus clouds may not produce significant precipitation, cumulus clouds that grow vertically and become larger can develop into cumulonimbus clouds. So cumulonimbus clouds, guys, these are definitely interesting clouds. They're associated with thunderstorms, heavy rain, lightning, and even severe weather events. When cumulus clouds continue to grow in height, reaching the level of the tropopause, they can transform into cumulonimbus clouds, which have a more extensive vertical structure and anvil-shaped tops, guys. We can also assess atmospheric instability in vertical motion using cumulus clouds as well. The vertical development of cumulus clouds reflects the presence of atmospheric instability and the vertical motion within the atmosphere at the time. As the warm air rises within the cloud, it creates updrafts, which transport moisture and heat upward. This vertical motion facilitates the condensation of water vapor and the formation of cloud droplets. The presence of cumulus clouds indicates the occurrence of convection, where rising air parcels interact with their surroundings, resulting in the exchange of heat, moisture, and energy. Cumulus clouds can serve as visual indicators for meteorologists and weather observers to assess the current and potential weather conditions. Their size, shape, vertical growth, and overall appearance provide valuable insight into atmospheric stability, convective activity, and the potential for precipitation or severe weather. By monitoring changes in cumulus clouds and their associated features, meteorologists can make predictions and issue weather forecasts. So basically, folks, cumulus clouds represent a specific cloud formation that provides important information about atmospheric stability, convective activity, and the potential weather conditions that are either ongoing or getting ready to happen. Their appearance and characteristics serve as visual indicators for assessing the state of the atmosphere and aid in weather forecasts and analysis. So it's definitely pretty interesting, guys. Definitely think that it's definitely a good cloud to take a look at for sure. And once you see these clouds, you can sort of assess what's actually going to happen later in the day, right? So if you see clouds like this on screen here, these are more fair weather cumulus clouds. This, obviously indicates the existence of fair weather. You can see their vertical growth isn't really much to write home about, right? As they propagate, most likely from west to east here, you can see that they just sort of fizzle out. They don't really. There's no growth. There's no. They're more isolated. They're not widely scattered everywhere. They're just, basically they grow up a little bit and then they just fizzle out. So these are fair weather cumulus clouds. On the other hand, you guys can see some of these growths occurring here, especially in the top left portion of the screen there. These represent thunderstorm type of clouds, guys. These are very, very, very intense vertical motions in the atmosphere that create this. You get those anvil clouds that start to form. You get the precipitation shields that start to fall. Yeah, if you guys see clouds like that are starting to billow up, and they start to cover much of the area like this, you can see blue sky here. And all of a sudden, the blue sky disappears, guys. It's definitely pretty interesting. But when that happens, you can definitely ensure and know that rain is on its way, guys. All right, guys, I thank you for joining me in this briefing about cumulonimbus clouds. I definitely hope that you guys have a wonderful rest of the day. Definitely hope you guys look forward to the next video. I know I definitely look forward to the next video, guys. Like I said before, if you are enjoying our content, make sure you hit that subscribe button, hit that like button, and share this information to those that need it the most out there, guys. And definitely leave a comment down below, so that way it definitely helps us. Your comments definitely help for sure. But always remember, guys, never stop chasing.